go. We got to fly. We've got some review. Where did we leave off yesterday? Right here? Ooh, we're a little bit behind. Here we go. Got to be able to do order of operations. Can you do order of operations? 3 times negative 2 divided by 3 squared minus negative 2 cubed minus negative 2. What do you get on top?
Negative 6.
Negative 6 over 9 plus 8. What's 9 plus 8? 17 plus 2. And so I'm going to make common denominators. So 34 over 17. And you get 28 over 17. So be ready for order of operations. Simplify algebraic expressions. Sometimes people see parentheses, they automatically start distributing. Don't do that. Some people like FOIL this out. No, totally wrong. Just add. When you add these together, you combine like terms. So negative z and negative 4z make negative 5z, and 1 and 1 make 2. Just be ready. That can be represented multiple ways on the ACT. Okay. Then we have this. Distribute the negative. 3w minus 4y minus y plus 2w. Combine together. What do you get? Negative 5y plus 5w. If we square this, super easy. We get 9x squared plus 4y squared. Right? Nope. What do you got to do? Yeah, you got to do 3x minus 2y times 3x minus 2y. Please do not get this wrong in the ACT. I'll be very upset. No, I can't. 9x squared. What's the middle going to be? Minus 12xy plus 4y squared. This one, if you were to multiply this out, so we got the 2x minus 1 times x squared plus 2x minus 3. We won't do it. We'll just kind of review. Remember, we're going to multiply all these together. And we'll multiply the negative 1 by each one. Could you do that? Yeah, you sure could. No big deal. So how about dividing? What do you remember about dividing these things? Okay, so Patty says, I don't want to divide, I want to use synthetic division, which is dividing, but it's just a little bit different. That's what you're saying, right? Oh, you're gonna go like this. You can do that, it's a lot more work. Yeah, how do I know to put a 1 here? That's the solution of x minus 1. So I drop down the 1, and then what? Yep, 1 times 1 is 1. And then you add. For synthetic division, you add. That's why it's nicer. We multiply, we get 1. We add and get and we get 0. So we've got x squared plus x minus 3. So if they asked what's the remainder, you could just run it through synthetic division and find out it's 0, right? So they could ask, if you divide that by that, what's the remainder? And that'll be a question that comes up. Okay, you try next one on your own. Go. I don't know. Now I got to replan. I had a circuit inside. We'll figure it out. Okay, here we go. So you should have multiplied this out. We get 2x times the quantity. 3 to the 4th is 81. X to the 4th, y to the 8th. Now we multiply that. We got 162. X to the 5th, y to the 8th. That's our result.
How do you know when to time? When do you know when to time the exponents?
Right. So if you're confused, write it out. 3x y squared times 3xy squared times 3xy squared times 3xy squared. And when you write it out as multiplication, that should convince you at that point that's 3 times 3 times 3 times 3. and then you add the exponents in that situation. Like usually people don't forget what to do here. It's when they have it to a power that they forget what to do. Does that help?
Yeah.
I would write it out. All right. This one, what do I do here? Okay, 2 over 3. Okay, so if the 8y's move up top, then what do I have? Y to the 10th up top. Good. That's that. Do you know how to handle an inequality? I'm going to start by distributing the negative. Negative 3 plus x plus 2 is greater or equal to 2x minus 4.
Oh yeah, no, just like x minus 1.
So negative 1 plus x is greater or equal to 2x minus 4. So we subtract the x over. The 2x is over. I get negative 1 minus x is greater or equal to negative 4. As I add the 1, I get negative x is greater or equal to negative 3. What happens when you divide by the negative? So x is less than or equal to 3. Be ready to end up dividing by a negative at some point on the ACT. So your graph is going to have a closed circle on 3, and arrow is going to go off to the left. Yep. How about for the next one, solving graphs? Suppose you had that. We know how to do the solving, but this one has fractions. How would you deal with fractions? What is the common denominator? 3, 2, and 5? Oh, try again. 30. Thank you. So 30. So I'm just going to multiply everything through by 30. So I've got 30 divided by 3 times 2x. 20x. 30 times a half. 30 times 4. And then 30 divided by 5 times x is 6x. So once you get to that point, you know what to do, right? Yeah. The idea, though, is in order to get rid of all those fractions, is multiply through by something. I could save you a lot of time if you remember how to do stuff like that. Look at the next one. This is a key. You're going to have to be able to identify characteristics about a line on the ACT. Easy points, you want to get them. Consider the function 3x minus 2y minus 6 is equal to 0. This is a linear function. Why is it linear? How do we know what makes a line?
X is the first one.
Yeah, it's first degree. So first degree tells us it's that. It says determine the x-intercept. As soon as people see this, they want to go straight to y equals mx plus b. Don't do that right now. Think about it. X-intercept. What value do you know if you're finding the x-intercept? Y equals 0. So notice if y is 0, what would the x value have to be in order to make that equation true? 3x minus 6 is 0. So x is 2. Okay, we'll go back to Morgan's point. You're trying to find the y-intercept. What value do you know? X is 0. If x is 0, then what would the y value be in that situation in order to make that equation true? Not 3, but negative 3. If they do ask for the slope, then yeah, put it into slope-intercept form. If you're going to put it in slope-intercept form, you're going to subtract the 3x, and you're going to add the 6. You can do that too. Yep, so y is equal to 3 halves x minus 3. I plugged in 0 for x. So notice how the y-intercept does match up with what I had here, right? So I've confirmed my answer. What is the slope? Now, if I want to confirm if the slope is right, realize you could always make a picture. If the y-intercept is negative 3 and the x-intercept is positive 2, okay, look. Is the slope 3 halves? Sure is. See how I've confirmed my answer? Flip it over. If you want a line for an equation that's parallel, tell me about the relationship between two parallel lines. Slopes are the same. So what's the slope of the last one? The equation we just did. 3/2. So the slope of this line is going to be 3/2 as well. Every time you have an equation for line, you need slope and you need a point on your line. So we got 6, -2. Anybody remember the point slope form of a line? Y minus y1 is equal to m times x minus x1. Good. So this is going to be y minus what? So y plus 2 is 3/2 times so y plus 2 is equal to 3/2 x. What's 3/2 times -6? -9. Subtract the 2 and you get y is equal to 3/2 x minus 11. That's slope-intercept form. What's the relationship if the lines are perpendicular? So the slope is going to be, and then you would go through the same process, right? Let's just say we went through the process. Question.
How did you find the slope of that?
So it says it's perpendicular, and so
I mean for the first.
so because it's parallel to this line.
Oh, okay.
We good?
Yeah.
Okay. Suppose I give you a picture of the graph right there. What's the x-intercept? 4.5 or 9/2. What's the y-intercept? What's the slope? -2/3. Yeah, if you look at these 2 points, you would drop 2 and you would run 3. Are we okay with that? So, if you want to write an equation for a line, sometimes it's just as easy as looking at the equation. Y equals mx plus b. Okay, what is m? -2/3 times x plus what is b? 3. Equation for a line, done. Evaluate functions using function notation. F of -3 given f of x is 5 minus x squared minus x cubed. Go ahead, do it on your own, see if you can get it. Okay, you should have 5 minus -3 squared minus -3 quantity cubed, which will give you 5 minus 9. It'll be plus 27. 5 minus 9 is -4, plus 27 is 23. Yes, you can take your graphing calculator. You could type in the function and put -3 into the table and come up with the answer. Totally legal.
Illegal?
Totally legal.
Oh,
You could just write it all in your handy dandy little calculator and come up with the answer.
I love calculators.
Some people would argue that it actually takes less time to compute it manually. So you do you. All right, let's do something you don't know how to do. Suppose you have to do units of conversion. It says a bicycle is traveling at a speed of 20 feet per second. 20 feet per second. What is the speed in miles per hour? So you've probably done this in chemistry. Notice that we want to get miles per hour. So what that means is I need to get rid of feet and I need to get miles. So I need to divide by feet and I need to multiply by miles. Somebody give me a relationship between miles and feet. 1 mile, 5,280 feet.
Do I need to know that?
Yep.
For what?
Okay. Shh. Boys and girls, do you see how feet are going to cancel?
Yeah.
And you're going to be left with miles? But now you have seconds in the denominator. I don't want seconds in the denominator. I want hours. So I'm going to have seconds on top, and I'm going to have hours on bottom. Somebody help me out. How many seconds in an hour? Nope, there's 60 minutes in an hour. 3,600. Thank you very much. Okay. So notice as you multiply that feet cancel and that seconds cancel, and you're going to be left with miles per hour. So it's going to be 20 times 3,600 divided by 5,280. We got 13.64. Yeah, so those of you taking a science class, hopefully you've done some conversions, but just figure out what you got to multiply and divide by. Do you remember how I do compound inequalities? Compound inequalities are where there's more than one inequality. Tell me the two inequalities they set up here. -2. Yep. And then? Good. Those are your two inequalities. Are these going to come apart or together, or are they going to go apart? Which one? They're going to come together. This is a conjunction. Anytime it's joined together like this, they're going to come together. Watch. We'll work it out. I'll subtract the 3, and I get -5 is less than -x. I divide by a negative. I get 5 is greater than x. Make sure that you switch the sign. This one, subtract the 3, and you get -x is less than or equal to 5. Divide by the negative, x is greater than or equal to -5. So notice that if you plotted those points, -5 and +5, you'd have a closed circle and an open circle, and the arrows would be coming together. We're not going to do that for all of them. Notice the next one is a absolute value. Is this a great or is it a less than? Great or. So you know that it's going to be a disjunction. What are my two inequalities I set up? Greater than 5, just like it looks. And then the other one is close. X plus 2 is less than -5. Just change the opposite side. Just leave this part alone. We good? Okay, then you would solve for there. The next one, is it going to be a great or a less than? Less than. So it's being a conjunction. They're going to come together. I'm going to have 2x plus 4 is less than 10. And what's going to be the other one? Greater than -10. And then you would solve each. Okay with that? All right, they're going to have you solve quadratics. When you solve quadratics, what's the solution to the first set? X minus 2 times 4 minus x is equal to 0. What is x? 2 and 4. Whatever you plug in to make 0. Good. The next one, it's not equal to 0. Or I'm sorry, it is equal to 0, but it's not factored. What can you factor out? An x, and you get 3x plus 4 is equal to 0. What are your two solutions? Next one's not equal to 0, so what should you do first? So 12x squared minus 3 is equal to 0. Now what are you going to do? Factor out a 3, and we get 4x squared minus 1 is equal to 0. So that's the difference of two squares, right? 2x minus 1 and 2x plus 1. So x is what? Plus or minus 1/2? Try the last one on your own. Go. Okay, folks, common misconception that happens here. First of all, the fundamental theorem of algebra states this, that if it is a second-degree equation, how many solutions are there? There are 2. So some people will see a negative out front or a 3 out front, and they'll list a 0. It's only if there's an x out front that there's a 0. Get my point? So if it says squared, 2 solutions. Keep that in mind. Flip it over. Here we go. Square roots. Remember your square roots? Can you add those together?
No.
What do you have to do first? Common radicans. So 3 roots of plus 3. I'm sorry, that's 2. So how do you break down the square root of 18? 9 and dos, which is Spanish for 2. 50, 25, and 2. Good. So, first one sets up to what? 6 roots of 2 plus 15 roots of 2. What's 6 roots of 2 plus 15 roots of 2? Good. Do you multiply radicals? Okay, so you're going to get a 12 roots of 12. Is that simplified? No. So I have negative 12 times the root of 4 times the root of 3. What's the root of 4? 2 times negative 12. Good. Dividing radicals. What do you have to do to simplify this one?
Times by the square root.
Excellent. Everybody always says multiply top and bottom by the square root of 3. And I'm going to tell you there's an easier way, folks. Easier way. You want to see the easier way? Show you the easier way. 2 roots of 3, roots of 2. Do you agree root of 6 can be divided up like that? Yeah, done. 2 roots of 2. I'll show you a different problem, okay? How about this? How about I show you 20 divided by 5? Does everybody agree that that's 2 times 5 times 2? Right? So you get 4. It's the same thing. Same thing. Okay, and I'll show you one last time. What's the root of 6 divided by the root of 3? What's the root of 6 times the root of 3? Root of 18, right? What's the root of 6 divided by the root of 3? The root of 2. Root of 2. 2 roots of 2. Scientific notation, you remember it? What is 6.2 divided by 3.1? 2.0 times 10 to what power? Oh, what? What?
9.
What? 9. Yep. Negative 2 comes up top, makes 9. Good. Look at the bottom. We got 2 divided by 4, which is 0.5 times 10 to the 15th. Can I leave scientific notation as 0.5? Yeah, 5.0 times 10 to the 14th. Yep. You got to adjust it. Right. Front number's got to be between 1 and 9. All right. You don't probably have to remember how to graph rational expressions, but you should understand the nature of rational expressions, a little bit about their shape. Suppose you have the function 4x plus 2 over 3 minus x. We did graph that once upon a time. You're fairly good at it, too. Where is that undefined? At 3. So you're going to have a vertical asymptote at x equals 3. Do you see how that's a pretty simple question?
Yeah.
But that if you hadn't taken this class, it looks really tough?
Yeah.
Okay. So then the next one, negative 4 over x squared minus 3x, if we rewrite this as negative 4 over x times x minus 3, tell me where is that function undefined? And so you're going to have 2 asymptotes at x equals 0 and x equals 3. Now, some people, they always just look where the bottom is equal to 0. I don't think they'll give you this problem, but just as a reminder, look at the next one. We got x minus 1 over x minus 1 times x plus 1. See that? So, where is it undefined? Plus or minus 1. So some people say you have asymptotes at positive 1 at negative 1. And that's not true. Notice how these cancel out? If you remember, that means that there's a hole that exists. Remember when we had that? If it divides off, that means that there's a hole. So you only have a vertical asymptote at negative 1. Again, I know what happened. I know it was quick, but I'm writing down all the things that the ACT say that they would cover to give you scores between 20 and 32. That's what I wrote down. Okay? That was my target. All right. Let's talk about sequences. Determine the next term of the sequence. You got two. You got one there, and then you got one on the other side. See if you can figure out the next term. Go. All right, what's the next term on the bottom? Because your ratio is equal to 3. You multiply by 3 each time, right? So 162. Very good. We call that geometric. If you are multiplying each time by a certain number, it's geometric. And the formula for a geometric sequence is the a sub nth term is the first term times r to the n minus 1. Have you seen that before? Third hour told me they had. I will show you how to write a rule for it very quickly. And just to be clear, the most common question to ask you on the ACT here would be the next term. The other question would be what the ratio is. The other question would be, is it geometric or arithmetic? I don't think that they'll ask you this, but if they did ask you the rule for the sequence, it's just this. A sub n is equal to, what's the first term? 2 times, what's the ratio? 3 raised to the n minus 1. That's all it is. That's all you got to do. So let's look at the next one. What's the next term here? Negative 55. How'd you get that? Yeah, so there's a common difference. The difference is equal to negative 15. This is arithmetic. So the most common question is going to be what's the next term? The other question might be what's the common difference? And then identifying it's arithmetic. The formula for an arithmetic sequence is a sub n is equal to a sub 1 plus, so instead of times it's plus, the difference times n minus 1. So it's very similar to the previous one we saw. So what is a sub 1 in this scenario? 5, and what's the difference? So it's minus 15 times n minus 1. Don't worry if you don't know the rule formulas. That's not as big of a deal. Do you know how to graph things? Y equals x minus 4 y squared minus 3. What shape does it make? Tell me about its shift. Down 3? Right 4. Good. 1, 2, 3, 4, and down 3. We used to spend like 2 days practicing that stuff. Now we just do it. Because you're smart. You've learned a lot. Okay, there's my 2 cents. Here we go. How about this shape? What does that shape look like? Close, not a line. A V. Upside down or right side up? Upside down. Shifted to the left 2. Avery has this way of smiling. I don't know if I'm like, do I look funny? Or does she just like the math? Or like, do I have a booger? She's like, Mr. Guys, like, you gotta clean yourself up, man. Okay. Domain and range. Do you even know what the shape looks like? Yeah, good. Close. It doesn't have a bend, it just starts and curves. Boom. Got it? Okay, let's look at this. Y is equal to the root of negative x minus 5 and then the plus 1 on the end. I'm going to factor out that negative. So somebody tell me, what is the horizontal shift? Right 5. 1, 2, 3, 4, 5. What does the negative on the inside do? What kind of flip? If it's on the inside, it's a horizontal flip. If it's on the outside, it's a vertical flip. So instead of going this way, it's going to go that way. What does the plus 1 do? Up 1. So this graph looks like that. So when it asks for the domain is the all possible x values, which will be what? Negative infinity to positive 5 with a bracket. Or in other words, x less than or equal to 5 if they wrote it as an inequality. What would the range be? 1 to infinity, or y is greater than or equal to 1. Good job. Lots of review. Your assignment is to complete your ACT review packet or your practice test by Thursday. Tomorrow is our final day of doing this review. We're going to knock it out. What do we have left? Well, we got a little bit of like some function stuff that we've covered, a little bit of trig stuff, but you remember all your trig stuff, right? A little bit of logarithms, and then look at after that. It's just good old geometry. Let's roll. Yeah? A little bit of geometry, a little bit of stats, and you're going to be ready to go. All right.